you enjoyed the first episode about factoring. Here is the second episode, entitled Combinatorics. Combinatorics is something your teacher might not have told you about in school. He might have mentioned it, but it's not something grade 7 people use. Here is the heart of combinatorics. Now what's this? You don't know what this is yet, but I'm going to teach you about it later. But first, let's go on to factorials. The factorial button is something you might have played around with your calculator. It looks like this. Here's an example of how to use it. 3 factorial is equal to 3 times 2 times 1 equals 6. 5 factorial is equal to 5 times 4 times 3 times 2 times 1 equals 120. And 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 40,320. Before we go on to this, let's have some more fun with factorial. Let's do one last example. 10 factorial divided by 7 factorial times 3 factorial is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 7 times 6 times 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. All of these cancel out. So we get 10 times 9 times 8 divided by 3 times 2 times 1. If you evaluate this, you get 120. Hey, I basically led you to the definition of what this is. This is equal to 4 factorial times 2 factorial times 4 minus 2 factorial. So 4 factorial over 2 factorial times 2 factorial. This is pronounced as 4 choose 2 or 4 taken 2. But personally, I like 4 choose 2. Evaluating this, we get 6. So I basically led you into doing 10 choose 7. This is the same as that. Now, let's go on to some real-world applications of this. Let's try example number 1. How many ways can we choose 2 players out of these 4 people to send 2 of them into the chess championships? Now, let's name them A, B, C, and D. Now, I did not name them. Their parents named them A, B, C, and D. Wow! Now, we can just list all the ways we can choose the players. That's AB, AC, AD, B and C, B and D, C and D. That's 6 ways. But there is another way to do this. There are 4 people, right? You have to choose 2, right? 4, choose 2. Now we've already evaluated 4, and this is equal to 6. Magic. Let's try our second example. There are 8 books on a shelf. 5 of them are Prentice Hall Algebra 1 books, and 3 of them are beginning algebra books. In how many ways can we arrange the books? Think about it for a minute. Notice that we can just choose the 5 positions where the beginning algebra books will be placed. So out of the 8 possible positions, we can choose 5. Try to solve this for a minute. We get 8 factorial divided by 5 factorial times 3 factorial. And this is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. This is equal to 56. Great. So this is our answer. Wow. Wow! Let's have our last question, and this question actually has a source. It's from the 2002 ANC 8, problem 21. Harold tosses 4 coins. In how many ways can he get more heads than tails? Now we actually have to split this problem into cases. Case number 1. Harold gets 2 heads and 2 tails. We can choose which of the 4 coins will be heads. That's equal to 4 choose 2, 6. Case 2. Harold gets 3 heads and 1 tail. That is 4 choose 3, 4. Case 3. Harold gets 4 heads and no tails. That's equal to 4 choose 4, which is just 1. Now, why is this 1? And 4 factorial over 4 factorial, 0 factorial. 0 factorial is equal to 1. So we can use erases here is equal to 4 factorial divided by 4 factorial equals 1. Now we add this up, 6 plus 4 plus 1, and we get in total 11. And that is our answer. Now, let's proceed to mathematical applications of combinatorics. First, try to solve this. I'll give you some time. You should have gotten this. X to the 4 plus 4x cubed plus 6x squared plus 4x plus 1. Look at the coefficients. 1, 4, 6, 4, 1. You might notice this as Pascal's triangle, but there is another pattern to it. 1, 4, 6, 4, 1. 1 is equal to 4 choose 0. 4 is equal to 4 choose 1. 6 is equal to 4 choose 2. 4 is equal to 4 choose 3. 1 is equal to 4 choose 4. Wow, that's magic. Wow! Let's try another example, but this time instead of Pascal's triangle, we use combinatorics. Quantity 2x minus 3 cubed. This is quite hard, but we're going to make it through. Let's first do this. 3 to 0 multiplied by 2x cubed times negative 3 to 0 plus 3 choose 1 times 2x squared times negative 3 to the first power plus 3 choose 2 times 2x the first power is negative 3 squared plus 3 choose 3 2x to the 0 negative 3. Let's first evaluate this. We get 1 times 8x cubed times 1 plus 3 times 4x squared times negative 3 plus 3 times 2x times 9 plus 1 times 1 times negative 27. Let's add all of this. We get 8x cubed plus, actually minus rather, 56x squared plus 54x minus 27. That's our answer. That's quite cool. But we're running out of time right now in this video, so I'm going to end the episode here. Thank you very much for watching and hope you enjoyed it.